Hello everybody, welcome into another lesson. So today we are going to talk about, we're going to start a three-part lesson on linear equations and their graphs, which is part of the coordinate geometry unit. And again, a lot of this is going to seem like review of algebra to you guys, which for good reason. This is where algebra and geometry overlap. You may have seen this before, the standard or general form of a linear equation. You have Ax plus By equals C, where you have A, some arbitrary coefficient on the x term, plus B, some arbitrary coefficient on the y term, equal to the right-hand side C, which is some constant. That is the general form of a linear equation, or the standard form, which is what we'll refer to it to. Some books refer to it as standard, some refer to it as general. It really depends on your textbook and your teacher, but I refer to it as a standard form. But the idea with the standard or general form of an equation is that you can use the x and y intercepts. You can find the x and y intercepts of a line, because the graph of a linear equation is a line, as the name implies, linear line. This enables you to easily find the x and y intercepts. You just plot those points and then you draw a line through them. So we'll do some examples here. So let me just erase that. I think we have a good grasp on what that actually is. Say, for example, you have something like 3x plus y equals negative 18, all right? So you have a linear equation in standard form, 3x plus y equals negative 18. The idea is we're going to find the x and y intercepts of this line, and we're going to graph it. So in order to find the x-intercept first, so to find the x-intercept, what would be true for that? That's where the graph crosses the x-axis. Well, if something's crossing the x-axis, your y-coordinate's always 0, right? If it's right on the x-axis, you have a y-coordinate of 0. So what that means is you need to set the y value equal to 0. You set y equal to 0 itself in order to find the x-intercept, because the x-intercept is when, again, your graph is crossing the x-axis itself and the y-coordinate's always 0. So if I set y equal to 0 in this equation, I'm going to end up getting 3x equals negative 18, which would give me an x value of negative 6. That means my x-intercept would have to be at negative 6, 0, right? So my x-intercept for this particular graph would be at negative 6, 0. So let's go ahead and plot negative 6, 0. 4, 5, 6. All right, so here's the point negative 6, 0 right there. There's the x-intercept. Now to find the y-intercept, it's very similar, but finding the y-intercept, so if we think of the y-intercept of a line, that's when the graph, when it intercepts, it crosses the y-axis. If something is truly crossing the y-axis, your x-coordinate is always 0. So therefore, if your x-coordinate's always 0, to solve for the y-intercept, you're going to set the x equal to 0. To find the y-intercept. If I set x equal to 0 in this equation, that would literally give me y equals negative 18. So the y-intercept would be at 0, negative 18. So now you're just going to plot 0, negative 18, which is all the way down here. Then all I have to do is draw a line and connect them, and then go through them. Continue through those. Probably not the straightest line, but that's what the graph of 3x plus y equals negative 18 would roughly look like. when you connect the x and y intercepts. You just basically you plot your points and then you connect the dots with a line, then you continue through those points on either side. That's really all that is. I have 5 more problems here. We're going to do 6 examples total. We just did one of them. So using the general form of an equation is actually pretty easy, or the standard form as I prefer to call it. Most books prefer the term standard, so do most teachers, so we'll go with that. They can be used interchangeably. You might hear me use them interchangeably, so don't be surprised if you hear me use them both, but alright. Let's set up our next equation here. The next linear equation. Let's see. We have, okay. So we have 4x minus 5y is equal to 20. So we have the linear equation 4x minus 5y is equal to 20. Again, the idea is we want to find the x and y intercepts, plot those points, connect those points with a line, and then go through them. Then you'll have the graph of your line for this equation. So let's start out with the x-intercept. So let's find the x-intercept. That's going to be what? When y equals 0. So you would take your 4x, set that equal to 20, since y is equal to 0, you get x equals 5, so in other words, your x-intercept would be at the point 5, 0. You have an x-intercept of 5, 0. So let's find where 5, 0 is on the graph. There's 5, 0, okay. Now let's do the same for your y-intercept. Your y-intercept, again, is when x equals 0. So in this equation, if x equals 0, you would just get negative 5y equals 20. Well, that's going to give you, of course, y equals negative 4. So you'll have a y-intercept of 0, negative 4. Okay? So your x-intercept is 5, 0. Your y-intercept is 0, negative 4. Let's find 0, negative 4, which would be right here. Now all I have to do is connect the dots and then continue through them. And there's my graph of the line 4x minus 5y equals 20 by connecting the x and y intercepts together. Got 4 more problems. Alright, let's erase all this here. Let's say we have the equation. This time we have 3x plus 2y is equal to 12. So we have the equation 3x plus 2y equals 12. Well, again, let's start out by finding our x and y intercepts. So to find the x-intercept, right, we're going to do that. To find the x-intercept, you set the y equal to 0, which would just give you 3x equals 12. Well, 3x equal to 12 gives you x equals 4. So then you would have the x-intercept of 4, 0. So let's go ahead and plot the point 4, 0. That's going to be found right here. Okay. Now we found our x-intercept. Let's find our y-intercept. to find the y-intercept, again, you're going to set the x in the equation equal to 0, which would just give you 2y equals 12. Which, solving for 2y equals 12, that would give you y equals 6, so you would get a y-intercept of 0, 6. That would be the y-intercept is at 0, 6. So let's plot the point 0, 6, which would be right there. And then now that we got our x and y intercept plotted, let's just connect the dots and go through them. That's all this is. So there is the graph of 3x plus 2y equals 12. Now wait till we get to Algebra 2 when we get into quadratic and even higher degree equations, and then we have rational equations and square, like the root equations and absolute value ones and all that. When we graph those, it's really cool, some of the stuff you get. Graphing can actually be cool. I know it seems boring right now because we're stuck in linear mode. I know we did some quadratic graphing in Algebra 1, but trust me, that's coming back full force here very soon, because in about a week and a half's time we'll be in Algebra 2, so it's going to be a lot of fun. Okay, 3 more problems. Now this is a little bit different. It's kind of like the other equation, but this one is 3x minus 2y equals 12. So this equation is 3x minus 2y equals 12. That's definitely going to change things with the minus. So again, start out when you're given the general form, find your x-intercept. So the x-intercept, of course, is always when y equals 0. If y equals 0, that's just going to give you 3x equals 12, which would give you an x value of 4, meaning then the coordinate of your x-intercept can be found at 4, 0. So we got 4, 0 for the x-intercept. Let's go ahead and plot that right here. Okay, now we found our x-intercept and plotted it. Let's find the y-intercept. The y-intercept, of course, in this case is when x equals 0. If x equals 0, you get negative 2y equals 12, which would give you y equals negative 6. So you would get the y-intercept point at 0, negative 6. So now let's find 0, negative 6 and plot that point, which would be right there. Now that we've plotted both points, let's just connect the dots and continue through them. And there you go. There is your graph of 3x minus 2y equals 12. All right. So, got 2 more problems, but let me just rebuild this coordinate plane real quick. All right. On to the last 2, then we're almost done. Now, we have 5x plus 8y equals 20. So we are given 5x plus 8y equals 20. Well, let's go ahead, let's start out here, let's find the x-intercept. So start out with your x-intercept. Okay, so to find the x-intercept, you set the y equal to 0. That would just give you 5x equals 20. Which then, of course, would give you x equals 4. For the coordinate of the x-intercept being 4, 0. Boy, they sure love 4, 0 for their x-intercepts, I'll tell you that. They sure love 4, 0 with this one. Alright, so that's plotted. Now we need to, of course, find the y-intercept. Well, To find the y-intercept, again, you're just going to set x equal to 0, which would just give you 8y equals 20. Well, 8y equals 20, that would give you y equals 20 over 8, which both have a common factor of 4, which would give you 5 over 2. Y equals 5 halves, so the coordinate of your y-intercept would be at 0, 5 halves. So we have the x-intercept at 4, 0, the y-intercept is at 5 halves, 0, 5 halves. Which, as you know, 5 halves is like 2.5. So that would be about right here at 0, 2.5. Now we just simply connect the dots and go through them. And there is your graph of 5x plus 8y is equal to 20. I got one more problem here. Come on. Try not to destroy my whole coordinate plane, you know, because that's kind of important. I'm going to need it for this lesson and actually the next lesson. Because the next lesson is very similar to this, only it's a different form of the equation. Alright, so last example for this lesson is going to be, alright, so we have 3x plus 4y equals negative 18. So we have the linear equation in standard form, 3x plus 4y is equal to negative 18. Well, start out finding your x-intercept, okay? The x-intercept is going to be when y equals 0, which would just give you 3x equals negative 18. Well, 3x equals negative 18, that means x equals negative 6, so your x-intercept would be found at negative 6, 0. So now that we know the coordinate of the x-intercept to be negative 6, 0, let's go ahead and plot that, which is right here. Okay, now we found our x-intercept, so what about our y-intercept? Well, let's see. So the y-intercept can be found, of course, by putting 0 in for x. That would simply give you 4y equals negative 18. Which then, of course, y would equal negative 18 over 4, which both have a common factor of 2. That would give you negative 9 halves. Y would equal negative 9 halves, meaning your y-intercept is at 0, negative 9 halves. Which negative 9 halves would be negative 4.5, if you're wondering what that is. So yes, you can get fractional answers. Okay, so I need this marker to plot the point. So 0, negative 9 halves, that's going to be down here at 0, negative 4.5. So now I've plotted the x and y intercept. Let's go ahead and draw the line through. And there is the graph of 3x plus 4y equals negative 18. So yes, that is it for this lesson. The next lesson we are going to talk about the slope-intercept form of a linear equation and what all that means and graphing those. So I hope everybody has a good day. Take care.